still not got it. It's
got it now?
Yep, there it is. There you go.
Okay, good. All right, this is lesson 23. Now, in the YouTube connections, they haven't put anything with them that linked up with it until this last file. And we're going to talk about what they linked up with it. So we're going to have to do some discussing about it. So if you go to the links, you'll find that in lesson 22, they put something right underneath it. And we'll talk about what they put there. All right. So this is from my flood book. And the gap in time was because my wife got sick and she passed away, and I got COVID during that time. And so we've missed several weeks here, probably 6 weeks. So we're back again, recording again, right? What we had is the YouTube system, somebody with YouTube linked something with our file, with our last lesson. And what they linked with our last lesson was flat Earth, the flat Earth error. So the flat Earth position, the idea that the Earth is flat. And have here, they appear to be drawing an analogy between what we are saying and teaching and the flat Earth view. But what I'm teaching here and saying is scientific, and it's documented by scientific journals, right? The fallacy of a false analogy, that's what they're doing here. They're drawing an analogy between the flat Earth view, flat earthers, and what we're teaching. It's a subtle way of doing it. And their argument is P is true because I drew a false analogy. When responding to the arguments made by creationists, the atheist may draw the analogy that the creationist is a flat Earth advocate. He's just like a flat Earth advocate, his position is. But our position has substance to it. I call attention to the fact that the YouTube website managers linked the last file with the flat Earth idea. You can go to the last lesson and see it, see the linkage. It's very subtle, but they did tie it with it. And here's a book that did this, and they couldn't answer Henry Morris. Henry Morris now has 69 other equally valid arguments against conventional geochronology, and he published all 70 in a laundry list of his 1977 book, The Scientific Case for Creation. Now, this is a good book. This is still 30 fewer than flat earther William Carpenter offered in 100 Proofs that the Earth's not a globe. See, what he's doing, he's saying, I don't have to answer Henry Morris's arguments because I've made it, I'm saying he's just like the flat Earth view. In other words, I don't have to answer him. And so this is a way to get around answering the arguments. I think some of the arguments made by Morris are very good, and they haven't answered them. So how do they do it? They just say, oh, it's just like flat Earth view. And that's what he's done here. Now, this book here's the title of the book, Science Confronts the Paranormal, and Buffalo Prometheus Books. Prometheus Books produces a lot of books that are atheistic. And they do attack such stuff as some of the Scientology and some other things, witches and astrology and stuff like that. But there's no substance to those, but there is substance to what we're saying. In this book, the author is linked by analogy the flat Earth idea with arguments by Henry Morris. But there's no logical link between these arguments. There's no logical link between Henry Morris's arguments and the flat Earth view. They just did it so they won't have to answer his arguments. Is that clear? Any questions or comments? And that's what they appear to be doing with us. Now let's go to planets and mountain building. All right. When the cause, and this is right out of a geology book or a geology article in a very reputable journal. And again, this is all in the book, documented, chapter 8. When the cause of orogenesis. Now, orogenesis The word oros is the word for mountain. Genesis is the beginning of it. So that means when the cause for the beginning or how mountains were formed can be stated in precise physical terms, and when the result of repeated application of the fundamental orogenic process can be shown to be adequate to produce the complexities of geology, then geology and physics of the earth will have merged. This has not yet been achieved. This is Wilson. Keep that in mind. They still haven't achieved it. I will say that there is a new theory out now about the core of the earth. And I just saw it recently, just in the last few weeks. Haven't studied it yet, but I'll try to get to it and study it later and see if there's some articles I can read and see what they're saying. They've got another view of some things in the core of the earth. Okay. All right. Eardley, and this is another article, in discussing the process of mountain building, states the cause of the deformation of the Earth's outer layers and the consequent building of mountains still effectively evades an explanation. These are geologists, and they're not just garden variety geologists. These are guys that are publishing in reputable journals, refereed journals, and they admit they still don't know how mountains were built. They don't have a way to explain it. Now, that doesn't mean my explanation is correct. I understand that. But Eardley then goes on and discusses the weaknesses of several theories of mountain building. He takes them to task. Hapgood sums up the inability of the atheistic uniformitarian geologists to explain mountain building processes. He says, yet it is agreed by geologists that no theory has so far satisfactorily explained mountain building. They can't explain mountain building. They don't have a satisfactory theory to explain it. All right? You have to explain it in accordance with the laws of physics. And you cannot explain it by the natural processes. Now, this book by Hapgood, which I have the book, Albert Einstein wrote an endorsement of the book. And he wrote it in the foreword, I think. He endorsed the book. That's pretty high-powered endorsement, in my judgment. Okay. Any questions or comments? Again, we have three sources. Now, let's look at what the Bible says about mountain building. The mountains rose, so they rose. The valley sank down unto the place which thou hast founded for them. Thou hast set a bound that they may not pass over, that they turn not again to cover the earth. All right, this is probably Hebrew parallelism. Set a bound and not turn not again. It's probably referring to the flood waters, okay? In Genesis 9:11, I will establish my covenant with you, neither shall all flesh be cut off anymore from the waters, by the waters of the flood, neither shall there anymore be a flood to destroy the earth. So here we have the mountains rising, and this is talking about during the flood. And so we have here now, the waters won't cover the earth again, right? Now, this is in the state of Colorado. I want you to see something here. See the tilt in these formations? They're tilted. And so they're not, something has happened that's tilted this. And so we see how they go in the tilted. I'm using my mouse, so hopefully you can see it here. There's a strata of rocks. You can just see them as they're layered. They're tilted. Here's another one. This is a layer rock. This is also in Colorado, and it's tilted. It goes uphill. And of course, I'm relatively flat down here, but that's the side of a small mountain, okay? Here again, it's more in Colorado, and you can see how the layers are tilted upward a bit. And again, you can see the layers of rock, okay? There's more. This again is still in Colorado. And pretty soon I'll get over into Utah. This is a trip I took. You see the layers as they go up. And of course, this is level. So they're tilted about almost 45 degrees upward, probably between 40 and 45 degrees tilt. Here's an interesting arrangement. And right here we have the layers right here as they move. And then we have a swirling of the effects here. And so you can see this rock as it's happened across here. So now we have, this is in Utah. You can see up here how they're tilted. This goes, and it goes in a kind of a circular arrangement up here as you go upward. We're going to see more of that as we get some more of these. This is in Dinosaur National Park, right? Here's one that's tilted almost like 70 degrees tilt. The layer of rock is. Something tilted. What tilted that? How did that get tilted like that? And here, this I think is still in Utah, but you can see the rocks and the layers of the rocks as they move like this. You can see how this goes in a circular pattern. And we're going to explain all that, how that happened, or how I think it happened, okay? This, of course, if you don't know what it is, it looks like sagebrush to me, right? This is in New Mexico now. I want you to see this. See this layer, and it goes, and it's not flat. Now, if you were laying down sediment and it was coming into a lake, it'd be flat at the bottom. It would go in the bottom, and the layers would be flat. But this is not. Something has tilted this, bent it upward. So this is called a syncline, an anticline, I'm sorry, right? New Mexico. Here you can see it even better right here, that same area where this tilts. So it's not flat. The layer of the rock is not flat. Now these right here, I think are drill holes where they put dynamite or some explosive to break the rock off so they can put the road in. Okay, that's all those are. Don't look for that for anything else. Here again, this is in the Arbuckle Mountains in the state of Oklahoma, south of Oklahoma City, roughly 100 miles south of Oklahoma City. You can see the layers as they tilt here. This is on Interstate 40. And I stop there and you can see how the layers go. We're going to see some more of these layers of rock that have been bent. You can see them right here. See these right here, they go upward like this. And they spiral downward. See right there? And this is in Arbuckle Mountains in Oklahoma again. You can see this. It's a little hard to see it, but over here you can see how they go down. It tilts downward. Now there's two names for this, the anticline and the syncline. I think the syncline can be remembered by it sinks down. S-Y-N-C-L-I-N-E. And anticline goes the opposite. It bulges upward. So what would cause that to happen? Again, you can see this some more. This is the same place, a little bit different shots and this is Arbuckle Mountains in Oklahoma again. These are the wonderful red cedar, eastern red cedar, which is just a pain in the neck. They're taken over. They're really bad. They're a nuisance tree. All right. Again, it's kind of hard to see it here, but you can see the tilting of it as it goes down, these layers of rock. And here's one right here. This is in the Arbuckle. Look right here, particularly where these arrows are pointing. See how it goes like this? And it goes up. What would bend rock? How could you bend solid rock like that? And the answer is no. You take a class in engineering and mechanical or civil engineering, and most engineers take a class in strength of materials. And you take, James, I'm sure you took some in physics, strength of materials type stuff. And if you take a rigid rock and apply pressure to it, at some point it'll just shatter, won't it?
Yes, sir.
Yes, it will. And so that's crazy. And we're told that this rock was rigid and was there for 1 million years and it just got bent. Well, I can't buy it. It'll break the rock. So we have a situation that's kind of hard to swallow. We have these rocks that have been bent. Now, if they were bent while they were yet plastic, but by that I mean they were still soft and pliable, that's okay. That's explainable. But you see, the atheist can't have that happening because his system won't allow it. Okay. And so they're still thinking in uniformitarian views to a large extent, even though they believe in some catastrophes. They certainly wouldn't believe in the biblical flood. Okay. Here's another one. You can see how they're bent. Let me see here. Hold on a minute. All right. The layers of my mouse. You can see that right across here. This is a little harder to see, okay? A little more difficult. Again, you can see some more layers. I took some more pictures, the same thing. Right here, see how these in the Arbuckle, see how they're tilted? These rock layers are tilted nearly about 45 degrees. What would tilt them? What would lift these up and tilt them? See, that's a good question. I wish someone would quit throwing their trash out. Sorry about that. I have to vent myself. They take a beautiful sight and throw trash out. Some people just have no respect. Again, we have here, we see the layers how they're tilted down. And so it sinks down. It's a syncline. Speed limit 65 there in Oklahoma. Okay. Mountains, it's at speed 70 elsewhere. Again, we have more of these along the road. Some more here. And you can see them how they tilt downward. Now, here's an anticline. Notice it humps upward, goes upward, anticline. What would take these rocks and take rigid rock and bend them? That's very interesting. They have a problem with it because they cannot get rocks to bend in labs. They just won't happen. They'll shatter. Most of these rocks will shatter. They won't bend like these things are bent. And here's another one. This is a good one. I got this off the internet. I don't know who that fellow is, but you can see how they're bent. What would bend those rocks like that? Well, if they're solid rocks, they're going to shatter. If they're still kind of soft material before it's hardened, that's easy to explain how it bent. But you see, they have these layers of rock being laid millions of years apart, so they can't have this happening. The atheists can't have it happening, but my flood model can. Any questions or comments? It can. Of course, these right here are drill holes where they drilled it and used some explosives to break off the rocks so they can put the road in. Here's another one so you can see it real well, an anticline. Again, what we have here is, see how it moves? It just bends in a circle. All these rocks were bent. Now, were they bent while they were still soft and pliable? That would fit the flood. All these are being layered, these layers are being deposited over a period of weeks or months, and it don't harden immediately or even days. And but if it's millions of years, you got rocks that are rigid and they're not going to bend. Again, the atheist has serious problems. All right, this anticline. All right. Here's a good one, and I got this off the internet and don't know exactly where this was found, but it's right off the internet. And see how these rocks have been bent like that? And they're not all shattered. They maybe have cracks in them, but you see how they're not shattered. Again, if you take rigid rocks and bend them like that, try to bend them in an elbow shape, those suckers are going to just shatter into gravel. But it didn't happen. This did not happen. That won't fit the atheist view because he has these laid over millions of years of time. The rocks were hardened, supposedly, and then they bent. There's no way they can do that. Here's another one. That's a very interesting one. That's like a pickaxe, a little small axe that they use. But here, see how it's bent upward? That just bowed right up. What did that? Another one, an anticline, how it comes up. All right. See how they bow upward? Anticline. Here's another one. See how these rocks are bent here? Right here. You can see it right here. So all these rocks got bent, and very interesting. They were laid, and then they got bent, and they didn't shatter. Oh, I have a problem believing that. I don't have a problem if these rocks were still pliable and soft and they hadn't hardened yet and they got bent. That would fit. Again, here's another one. See how the rocks got bent? And again, it won't fit. The atheistic model won't fit it. They should have shattered. Right? Any questions? Again, I took this off the internet. Here's off a geology website, an anticline and a syncline. Anticline goes upward like this. Syncline dips down like, I like to think it sinks down, syncline. That's how I remember it. Anti is opposite. It goes in the opposite direction. Anticline and syncline. Boy, here's another one. See how that sucker, how it bent down? That's at Provo Canyon, Utah. So that's a pretty good one right there. It sunk right down. And again, you mean all that sunk down and those rocks didn't fragment? Okay. Here's one at Fort Davis, Texas, syncline. You can see how it goes down and then comes back up. And the rock does. And again, these rocks here don't look like they broke, but they got bent. What bent them without breaking them? Interesting. And you just start applying some pressure to some of these type rocks, and those suckers will just shatter like crazy. All right. If you get an engineering degree in most universities, you'll take a strength of materials class, thermodynamics and strength of materials and mechanisms classes, even if you're an electrical engineer like I am, and you take all that. And but you take one of those classes and you'll find out right quick, rocks don't bend. All right. Here's another one. See, it's a syncline. Notice how it dips down. Get my mouse to move. See, it dips down. You see them up here too, and right here. Not as pronounced as some of these. There's a good one. See right here, how these rocks got bent down. Hey, we could just multiply these things over and over and over again. Scientists admit, geologists admit this happens all over the world. It's not a matter of a question of whether these are oddities. These are norms. They're found everywhere. All right. Now then, what do we have here? All right. We talk about tides. In the last lesson, we showed the Bay of Fundy. I think it had something like 50-foot tides under the real unique condition. Under some conditions, the tides get as much as 50 feet in the Bay of Fundy or close to it. That's the biggest tides in the world, in my understanding, the Bay of Fundy in Nova Scotia. That's part of Canada. And according to Thomas X measurement at Marburg, the M4 land tide, all right, now what are you saying, Marion? I'm saying in the font, this is a geology book, he says that we have, not only do we have tides in the water, but we have tides in the land. He said the M2 land tide has an amplitude, that's how big it goes up and down, of roughly 0.5 meters. Now, 1 meter is a little over a yard. It's 39.37 inches, so it's a little longer than a yard. So a half meter would be about 1.6 feet, roughly 1.6 feet, 1.6 feet approximately, somewhere thereabouts. So it goes up and down. That is, i.e., the Earth's surface rises and falls daily by 0.5 meter, about 20 inches. Naturally, this rise is imperceptible as there is no fixed point from which to measure the fluctuation, since the observer standing on the Earth undergoes the same motion. If you rise with it, you don't notice it. And they can measure this with satellites and other systems. They actually have measured it. So the crust of the Earth rises like 20 inches every day with tides up and down. And everything around you rises, so you don't notice it. So we have land tides. Now, let's think about this. The moon is about 250,000 miles away from the Earth. And they take the size of the moon and it causes about 20 inches of rise in the Earth's crust, right? What if the moon were closer? That's our question. Sensitive instruments capable of measuring small changes in the local gravity of small tilts in the Earth's crust indicate that the solid Earth is also subject to tides. This is another source, implying that the Earth does not respond as a rigid body to the gravitational attraction of the sun and moon. Now, the two main sources of our tides are the sun and the moon. And we do have tides from other planets, particularly Jupiter affects a little bit. Typically, an observer on Earth's surface will move up and down in 12 hours by as much as 500 millimeters. Well, that's a half a meter. 0.5 meter, about 20 inches. Say that MRF, that's me. I put it in there as 20 inches. Okay. Now, at the same time, gravity on the surface will change fractionally. This is a solid or elastic tide. Its amplitude is a function not only of the magnitude of the tide raising force, but also the elastic properties of the Earth. So how elastic is the crust of the Earth? Say that's a factor. And if it gets enough force, it can crack the crust apart. Okay, keep that in mind. Now, since gravitational forces are inversely proportional to the cube of the distance, so you take the distance and you take 1 over the distance cubed, or some value over the distance cubed. So you raise it to the third power, multiply it by itself 3 times. That's what you do when you cube it. Now, this is Wolfson and Pasikoff. This is a highly recognized general physics book for university level courses. The forces would have been extremely large with the planet coming within about 30,000 miles of the Earth. My claim is that the planet Mercury came approximately 30,000 miles from the Earth. All right. And what I did is I figured the forces that would be involved from the forces of gravity. Okay. This would be the forces of the order of magnitude to raise mountain ranges. If the planet Mercury came within 30,000 miles of the Earth, it would have enough force to elevate the mountains 30,000 feet to 25 or 30,000 feet up in the air. All right. Depends on how far away it is. Remember, it varies with inversely with the cube of the distance. Okay. If the moon came to within 15,000 miles of the Earth, remember it's 250,000 miles away roughly, its tidal force would be about 4,096 times what it is now. What I've done is I've done the math with it. And so what we have, if the present gravity of the moon causes the surface of the Earth to rise by 0.5 meters, and the forces were increased by over 4,000 times, the surface of the Earth would rise by 2,000 meters, about 6,500 feet, from the moon being 15,000 miles from the Earth. Okay. Now there's a limit to how close the moon could get to the Earth because the moon would fragment due to Roche's limit. We'll get to that later. So there is a limit. Any comments or questions? So with this right here, my model can explain the presence of mountains. If the planet that caused the Earth came within 15,000 miles of the Earth and had the mass of planet Mercury, my calculations show from gravity, it would raise the surface of the Earth by over 9,000 meters, 29,520 feet. And so we get mountains nearly 30,000 feet high with this. It would lift them up. Questions? Some mountains were probably elevated while the rock was still in a plastic state or pliable before it had hardened. The Rocky Mountains in the United States are probably elevated by this mechanism. And so they're elevated by this mechanism. So when the Earth then rises, some of those rocks would be tilted, like we saw them. Okay, rock layers that are bent. Again, we see this in New Mexico. You can see right here. This is in New Mexico. This is west of Albuquerque. And I can't remember exactly where it is west of Albuquerque, but it's about maybe 150, 200 miles west of Albuquerque is where this is. But you can see here how these layers go. They bend upward and they bend downward. So they're going up and down. So we see the layers. And again, these rocks, maybe they have cracks in them, but they still have a problem. They should have been shattered. And this, I believe, is back in Utah. I don't think this is New Mexico. I think this is something else I picked in. And we see some of these layers here. And they're layered, they're tilted again. Something tilted, that's in Utah. Here's another one. See how they're bent? These anticlines, they're bent up like this. And that's in Utah, near the park that I went to. Again, you can see them more. This is the same mountain, so they're bent. You see the bending of them. This one is not quite as clear, but we can see how it goes down like this, and then this goes over, and we have these layers again. Again, this one going like this, and then the other one going over like this. Layers like that. And again, if these rocks were laid in a lake, they should have been, the sediment should have been deposited in a level manner. Okay. Again, that's more in Utah. I believe this is also in Utah, but I can't remember. I'm sorry. You can see these layers. They are bent a little bit. And again, you can see the layers of rocks, how they're tilted up and down. They should not have been. They should have been level, unless the land was elevated. Again, we'll move on. This is more in Utah, okay? See how these are tilted here. Layers are tilted. And we can see them up here, how they're swirled upward. Okay. And, but this, if the flood came in tidal motion, it could give us layers like this here. And then if there was being elevated by the gravity of the planet, it would also give us layers, get tilted. Again, it's an anticline. This is in New Mexico. It's pretty evident here. It's in the same spot I saw earlier. See how it's tilted upward and goes over here like this. So it does this up and down, kind of wavy. This again is in Oklahoma. This is the rock layers that are bent. We have it here. Back in Colorado, we had this earlier. And tilted rock layers and more tilted rock layers. You go across here. Tilted rock layers. And these are in the Rocky Mountains. See your layers and how these layers are actually not level. They're bent. This is the Dinosaur National Monument. This is several years ago. That's me. And a friend of mine went with me from high school as a member of the church. And he and I went on a vacation together. He's a widower. He lost his wife about 5 or 6 years ago. And he and I are going to take a vacation together here in the next few months. We're just going to go off and go somewhere, get away, do some things. All right. So we were good friends all the way through high school. All right. His dad was a gospel preacher. This is something I didn't get to get into. It's the Dinosaur Quarry, and they had it closed off. They were working on it. So when I was there, it was the gate, and I shot this over the gate. It was blocked, and so they wouldn't let you in. I still would like to go back out there and see that. See this rock, though, it's tilted. It's swirled like that. Very interesting. And they've been quarrying dinosaurs out of here, dinosaur fossils. Again, you can see that quarry. See how these rocks are not straight, they're bent. The layers of them are. That was in Utah. Again, this is also in Utah. That was interesting. See how that rock here is tilted right there? And then you have these swirls up here in this. And so they're layered, just swirling around. Of course, waters that were very turbulent could do this. Turbulent waters caused by tidal actions. Right? Again, this is also in Utah. See how it swirls over. This is at that same dinosaur monument park. And again, this is another one of that same park. This again is back to the Arbuckle Mountains in Oklahoma and folded rock. Here's another one. This is Arbuckle Mountains. I took this off a website advertising the Arbuckle Mountains. That's a little better picture. I couldn't find this place, but I needed to go back here and take a picture myself of this because this picture is a little bit fuzzy. but this is from a website advertising, state website, I think, advertising. But you can see how it's tilted, how it's bent. There's an anticline, and then it sinks down the syncline over here, and then layers of rocks. And again, a long layer of rock that got supposedly bent and it didn't crack. Now, I see cracks in it here. There are. And maybe other forces later could bend it. All right. What we're going to do is we're going to come back and we're going to look at mechanisms for orogenesis a little bit later. All right. And we'll try to follow these up next week a little bit with some more material. Mountains are formed by the process called folding. Now, we need to come back and study this, folding, and they're formed by what is called thrust faults. And all of these will fit in with my flood model. These are some of their ideas of how they were formed. But they don't know how they folded and how the thrust faults occurred, what causes thrust faults. They're formed by metamorphic processes, and they're also formed by igneous processes. Now, these are different kinds of rocks. Metamorphic rocks are rocks that undergo change in their nature because of heat or pressure, and usually heat. And igneous rocks, and that has to do with temperature. There's two things that form these. Pardon me. The igneous rocks are, when they come in contact with magma, which is very hot, it changes the nature of the rock. And also when they're under great pressure, and they can change the nature of the rock. Pressure can cause heat just as well as heat. So it can cause the same effect as heat does. The gravity of Mercury, what I'm saying, lifted some sections of the crust of the earth as it came close to the earth. Right? The exchange of angular momentum, that's the momentum from something that's spinning that tries to keep it going at the same speed. Between the earth and Mercury slowed the angular velocity of the earth. So this slowed down the rotation speed of the earth. When this happened, this changed the oblateness of the earth. Now, oblateness is a measure of how it's not circular. What we have is the earth bulges at the equator. We'll talk about oblateness later, but if the oblateness changes, that is, the earth swelling at the equator due to the faster spinning, the faster it spins, the more it'll bulge at the equator. And the earth will bulge. But if it slows down, then that the equator distance around it will try to shrink, or it'll go down. It won't bulge as much. When that happens, these crust is going to elevate. And I think this changing of the circumference of the earth by reduced rotational speed raised the mountains such as the Andes. I think that raised some of them. Okay. Some plates moved against other plates. We have to figure out, I believe there are plates. I believe there's evidence of it. It's called foliation. Himalayan mountains and the Alps, apparently, from this method, from this process. So we have to figure out what causes plates to be formed and move. And I believe the planetary model will explain those as well. Of course, I believe we have volcanic processes. The Hawaiian Islands are the tallest mountain in the world. From the base of the mountain is in the big island of Hawaii. And it, from the base, its base goes way down deep into the ocean. So it's a very tall mountain from its base. And it doesn't reach as high as the Himalaya mountains. But if you go from its base up, it's taller than any of them, but it's volcanic. So mountains are formed by volcanic processes as well. So what we'll do now, next week, we'll come back and we'll hit these a little more, right? I want to go back to two other processes here. We have these metamorphic processes and igneous. The igneous has what they call, there's two processes. One of them is when heat is applied, and that's from magma. And until it spews out on the top of the earth, it's called magma. Once it's fused to the top of the earth, it begins to run out on the top, it is called lava at that point. The same stuff is called lava. That's igneous. That's from a Latin word for fire or heat. Okay, and so they're formed by these processes. And so if it comes in contact with magma, which is hot molten rock, the rock will then change, like shale will change. They'll go through process and change to another kind of rock. And they can take shale and put it into an oven and heat it up to these temperatures, and it will change. So they've proven that can occur. And I don't have any problem with it because I believe they can change. And also, if we have areas where we have layers of rock pushing against each other, such as a fault line, that these rocks can be under great pressure, and they can also change just like they were under heat, right? Now, metamorphic processes, we have two kinds of processes here, and some of the rock can come out on the lava, become lava, and it cools more quickly. And sometimes the magma gets trapped underneath and can't come out. And of course, the rocks all around it form like an insulator, and they keep the heat in for quite some time. So it cools off more slowly, and it forms a different kind of rock. So we have these two things occurring. But I believe thrust faults do occur. I believe folding occurs, and metamorphic process, igneous processes all occur. I believe they all do occur. All right. And I think gravity and mercury lifted sections of crust, and we'll look at it more as we develop it further. All right. Any questions?
Yes, Brother Marion, I got a couple of questions, Brother Williams here. When you was going explaining the anticline and the syncline, is that almost like topography synonymous with ridges and saddles, the Earth's surface, but just only in mountains?
Like a ridge?
Ridges,
Yes. The
saddles?
anticline, can you see my mouse? The anticline goes up like this. All right. And a syncline goes down like this. All right.
Right. Yes, that's
And
almost.
it bows downward, the syncline does, the anticline bows upward. All right.
Okay. Yes, that's to my knowledge. That's almost like ridges and saddles.
Yeah. Yes.
I learned in the military. Oh, yes. Another question. You think you'd have room for one more on that vacation?
Well, I don't know. Okay.
Fooling with you, Brother Mary. I left you a text. Yes, a text. So when you get a chance, sometime tomorrow, could you please give me a call? I'd like to discuss some things with you.
All right. I'll try to call you tomorrow then. Okay.
All right. Thanks, sir. Thanks for the class.
All right. We're going to close down now unless there are further questions. We'll start here with this next week.